Hello, my name is Andrew Hilton, and I've done my presentation on the horseshoe crab, and more specifically, how the biomedical industry has affected the horseshoe crab. So, first, I'd like to talk about why the horseshoe crab is important. Um, these are very vital organisms in their ecosystem, and in fact, they're keystone species on the Atlantic coast of America and the Gulf of Mexico. That is because their eggs are a major source of food for many different kinds of seabirds. Now, as far as human impact goes, we are very interested in the horseshoe crab because their blood contains a very important compound called limulus amebocyte lysate, or also known as LAL. This is an extremely important compound for medical testing, and this is something that we will dive further into in later slides. Okay, so next I would like to talk a little bit about the background information of the horseshoe crab. So the horseshoe crab are mostly found in estuaries, um, most commonly on the eastern coast of America and East Asia. The horseshoe crab is extremely old, and their fossils can date back to the Jurassic period, and many of their relatives can be dated to even farther back than that. So, in our discussion, I would like to focus mostly on the American horseshoe crab. That is because they are the biggest victims of the biomedical industry, but all horseshoe crabs face many similar challenges. For example, habitat loss, bycatching, biomedical harvest, bait harvesting, and climate change can all affect the population size of horseshoe crabs today. So next, we're going to talk about the current applications of the horseshoe crab in the biomedical industry. As I had mentioned before, the horseshoe crab is harvested for their blood. Their blood is very valuable because it contains a compound that is extremely sensitive to things like bacteria and endotoxins. So this compound lends itself very well to be used as a test for medical appliances and drugs to ensure that they have not been contaminated with either of these things. In fact, this test is so relied upon that the FDA requires that all drugs and appliances be subject to this test in order for them to be approved. Okay, so a little bit about the process that these horseshoe crabs go through, or also known as the farming of these horseshoe crabs. Um, Normally, the horseshoe crabs are captured from the wild. After they've been captured, they are then systematically bled in order to collect about 30% of their body's volume of blood. After they've been bled or gone through this bleeding process, about 13% of the crabs will then be sold off as bait to be used for fishing practices or any other number of uses, where the remainder will most likely be sent back out into the wild in the most convenient areas, which are often not the same areas that they're captured from. To give you a better idea of what the farming practice would look like, I have included a diagram here of the basic anatomy of a horseshoe crab. Now, as you can see, there's a midline stretching horizontally across the horseshoe crab. At this point, the horseshoe crab would be folded on top of itself, and then a needle would be inserted into its back that would go directly into the heart of the crab. This would allow them to extract the blood necessary from the crab. So now I'd like to talk about the effects of this bleeding practice. First, I'd like to talk about how females are targeted for their larger size and therefore greater volume of blood. Now, because of this favoritism towards females, we've now been able to see that this has caused a discrepancy in the sex ratio in some areas, meaning there's far too many males to females in a certain area. Um, it has been estimated that about 130,000 crabs are killed a year due to this industry. Now, as far as the mortality rate goes, as you can see here, the mortality rate for males are about 15%, where females, it can be as high as 29% due to the bleeding process. Um, After the bleeding process, it takes around 3 to 7 days for the horseshoe crab to regain its normal blood volume. And further than that, it takes about 4 months for the crab to regain its normal levels of amoebocytes. Um, it has also been shown that crabs that have been farmed have been found to have a far lower protein level in their blood after they have been used in this practice. Um, so, on a more global scale, the number of crabs harvested for this biomedical use has increased from 340,000 crabs in 2004 to over 610,000 crabs in 2012 alone. So, contrary to popular belief, there are actual alternatives to methods of horseshoe farming. Actually, since 1997, there was a study done at the University of Singapore that resulted in a synthetic test that would be able to substitute the LAL test. This test is known as the RFC test. This was achieved by cloning the DNA of a horseshoe crab and then extracting the necessary elements in order to make this test. Now, this was a big breakthrough because this allowed them to have a sufficient test that would make the issue of horseshoe farming obsolete. So many disliked this test originally because not only did it go against an entire industry, but they held on to the belief that it was not reliable enough. But as years have passed, studies have shown that it is indeed just as reliable and at times even more reliable than the former LAL test. It is just as effective at detecting endotoxins, and in many cases, it is far less likely to have false positives. So then the question becomes, why is it that to this day it has not been as widely used? In conclusion, I have found that the RFC test can replace 90% of LAL testing. Although this is not 100%, this is a great start and prompts me to wonder why this has not been more widely used in practice. This would greatly minimize the annual deaths of horseshoe crabs due to this industry. And as we all know, these horseshoe crabs play a vital role in our coastal environments. So in my opinion, horseshoe farming is outdated and quite abusive to our environment. And so, if we are capable to switch to a way of testing that will allow us to no longer depend on these practices, then I see no reason for us to continue doing so. Here I have included both my image and work citations. That is the end of my presentation. Thank you very much for your time. I hope you have a good day.